Okay, let me show you how to do a sample specific heat problem here. We'll work it out together. Feel free to pause anytime if you want to test yourself and then check your work. So the problem says that we have 100 grams of iron and they are at a cool 40 degrees. We're going to put those iron nails into 100 grams of water that is almost ice cold, 10 degrees Celsius. What will be the final temperature of the nail-water mixture? Well, if you recall from the reading, we know that Q equals MC times delta T. So we can do this twice. In fact, I do like to do it twice and then set the Q's equal to each other because I just find it easier to think about it that way. So we'll do one for the iron, and we'll do one for the water. Now usually you'll be given the specific heat capacity or you'll be asked to find it. So I will just tell you that the specific heat capacity for iron is 0.108, and we're working in grams here and degrees Celsius, so that value is using a unit of calories per gram degree Celsius. And then we know our delta T, the little triangle T, means final minus initial. Well, final is what we're looking for, and our initial temperature of the iron was 40 degrees. So now I can come over here and I can do it again for my water. So my Q equals my mass of my water times my specific heat capacity of water in calories is 1 calorie per gram degree Celsius. And then my change in temperature, we're looking for the final of the mixture, minus 10 degrees C. Now one important thing is typically your warmer object is the object that's going to lose heat. So I always say don't forget to pop a negative sign in front here. So I'll go ahead and circle that so you don't forget that. And now we can go ahead and distribute. So I've got 100 times 0.108 gives me 10.8 times T final minus 40 degrees Celsius. In this case, it's my grams have cross-canceled grams, and my units here are calories per degree Celsius. You'll see my degree Celsius will cross-cancel as well, and I'll be left with calories for my Q. And we'll talk about where that's going to go in a minute. So on the flip side, I'm going to go ahead and distribute my 100 times my 1 calorie for water. And what I'm left with here is 100 times final temperature minus 10 degrees Celsius. Again, the units on my new 100 value here, my grams cross cancel and I'm left with calories degrees Celsius. I'm going to go ahead and clear the page and rewrite this information on a clean sheet. Hopefully you'll be able to see it a little bit clearer here. So for iron, I've got that Q is negative 10.8 calories per degree Celsius times some final temperature minus 40 degrees Celsius. And I've got for my water, my Q equals 100 calories per degree Celsius times some sort of final temperature minus 10 degrees Celsius. Okay, so at this point, we could distribute even further, and we could say I've got a negative 10.8 times my T final plus, it's actually a minus and negative, because my negative 10.8 will distribute into this negative. So I'm just going to go ahead and call it plus 432 is what you should get when you multiply 40 times 10.8. On the water side, I've got Q equals 100 times some sort of final temperature minus 1,000, and then this 432 is measured in calories, and then this 1,000 is measured in calories as well. So now what I'm going to do is because these are both equal to Q's, and we're looking for the final temperature of them together, is I can set them equal to each other. So I just do that by saying that the change in heat here for the iron is equal to the change in heat for the water. So negative 10.8 T final plus 432 equals 100 T final minus 1,000. Now I'm going to go ahead and combine like terms. So I'm going to go ahead and add my negative 10.8 to both sides, and I'm going to add my 1,000 to both sides. So hopefully you're okay with me doing this in one step. So I get 1,432 is equal to 110.8 times something. Finally, when you divide both sides by 110.8, you get that the temperature of the system is going to come to approximately 13 degrees Celsius. It's like 12.9 degrees Celsius, which makes sense because water has a much higher specific heat capacity compared to iron. So iron's going to actually give up more heat than the water will. So I hope that you found this helpful, and I will see you in the next lesson.